Let's do one last problem. It's the last one in your notes. Show that the solutions of the equation 4x squared minus 24x plus 37 equals 0 are complex conjugates of one another. And we could use quadratic formula, or we could use completing the square. Let's use completing the square on this one. Right? It's not too bad for completing the square. Right, so let's take a look here. So if we're solving using completing the square, the very first thing we're going to do is divide all terms by a, right? Right, so we'll divide everything by 4. So we have 4x squared minus 24x plus 37 equals 0. Divide by 4. So now we're going to have a little bit more complicated one in your notes. I did one that wasn't in your notes. Now we have one that is in your notes. So that would be x squared minus 6x plus 37 fourths equals 0. Our next step is to isolate the constant. So we'll isolate c. So that just means we're going to subtract 37 fourths from both sides. So that would give us x squared minus 6x, I'm going to leave a space, equals negative 37 fourths. Right? And then remember we add b divided by 2 squared to each side. So that's going to be plus negative 6 divided by 2 squared. So I can fit that in there. Plus negative 6 divided by 2 squared. I can, but it's awful close to this. Let's just move that over. All right, and then we'll simplify. So we have x squared minus 6x. Negative 6 divided by 2 is negative 3. And negative 3 squared is 9. Right, on the other side, we'd have negative 37 fourths. And we'd have plus 9, right? But we need to change 9's format so that it has a denominator of 4, but still equals 9. Well, 4 times 9 is 36, and 36 fourths equals 9. So just as a little reminder, 36 fourths is 9, right? We just changed it so it had the same denominator as the fraction that's already there. On the left-hand side, we can factor that. That's just going to be, that's step 4. Let me add that in there. Factor. That's going to be x minus 3 all squared, right? So always going to follow the format x plus or minus b divided by 2 all squared. On the right-hand side, we can combine those. That would be negative 1/4. Now we can take a square root of both sides. And then our last step would be to solve for x. For x. Just barely got that in. And this is an x. It looks a little like a y. There. Now it looks like an x. All right, so take square root over here. Equals plus or minus square root of negative 1/4. Square and square root cancel, so this is going to be x minus 3 equals, and that is a perfect square. Square root of negative 1/4 is going to be 1/2 I. And you can put the I next to the 1/2, or if you want, you can make that I divided by 2, same thing. All right, and then our last step is to solve for x. I'm just going to give myself a tad more space. And so we have now add 3 to both sides. X equals 3 plus or minus 1/2 I. And the question was, are these complex conjugates of one another? Well, we have 2 complex solutions. We have x plus 1/2 I. Oh, excuse me, 3, not f, not x. 3 plus 1/2 I, and 3 minus 1/2 I. notice that the only thing that differs is the sign between them. So if you have the exact same terms and just the sign between them differs, they are complex conjugates. So these are complex conjugates, or our solutions are complex conjugates. And there you go. All right, so we did show that the solutions, and actually this will be true for any quadratic equation that has complex solutions, that our solutions will actually be complex conjugates, right? Because we're going to have the same value that we're isolating from x, and then we're going to be adding the positive square root and the negative square root, and if it's a square root of a negative number, that's going to include I. Right? So that's the end of this podcast. Thanks for watching, and bye for now.